So here's an example problem that you could see. The question could ask you to list the compounds in order of boiling point. So we'll order them from lowest to highest. The first step when you see a question like this is figure out what intermolecular forces they have. So remember, for intermolecular, we've got London, dipole-dipole, and hydrogen bonding. So the increasing strength from London to hydrogen bonding will also increase the boiling point. If two compounds have the same intermolecular forces, then we look at the number of electrons, because number of electrons can also increase the boiling point when we're comparing two substances. Okay, so we'll have a look at the substances that were given and list off the intermolecular forces. So H2S is polar. Okay, everything has London forces, so this will have London. It's also polar, so it's going to have dipole-dipole. There is no hydrogen bonding. For hydrogen bonding, remember you need to have an HO, an HF, or an HN bond. So in H2S, we don't have any of those three. So those are our only two molecular forces. For water, obviously we have London. Water is polar, so we have dipole-dipole. Also, we have an HO bond, so we have hydrogen bonding. LiCl, lithium chloride. Lithium is a metal, which means that this is ionic. I know that if I look at my list here, this is the only ionic compound listed. Ionic compounds have extremely high boiling points and are always higher than molecular. So right away, I can put number 3 as my highest. Without even comparing the rest of them, I know that this is the only ionic on the list. It's got to be the highest. CBr4. Carbon is group 14. And it's bonded to all of the same type of element. It's bonded to 4 bromines. So it's nonpolar, which means it only has London forces. HCl has London. It's also a polar molecule, so it's dipole-dipole. Okay, and it does not have hydrogen bonding. We don't have an HO, HF, or HN bond. Methane, just like number 4, I've got a group 14 carbon, and it's bonded to all the same types, so all it has is London. Now we can start comparing these. So the only other one on my list, so this was the highest, the ionic. The only other one on my list that has hydrogen bonding, so that'll be the strongest of the molecular, is water. So water is going to be the second highest compared to salt. Okay, now we look what's going to be the lowest. So the lowest are definitely the ones that only have London forces. But 2 of these contain atoms with two of these molecules both have London forces. So that's when we want to look at comparing the number of electrons. So increased number of electrons increases the boiling point because there's greater London forces. So number 4 or number 6 is going to be our lowest. This is when we do have to look at the number of electrons. If you add up the number of electrons in CBr4, each carbon has 6. Okay, each bromine has 35 total electrons. We're not just looking at the valence, we're looking at all of them. So add that all up, we've got 146 electrons in this molecule. For CH4, for methane, carbon has 6, each hydrogen has only 1, so that gives us a total of only 10 electrons. So even though these both have London forces, this one is going to be much stronger because we've got a larger number of electrons. So just like cars on the road, the more number of cars you have, the greater likelihood of a traffic jam. The more electrons you have, the more likelihood you're going to have London dispersion, so uneven distribution of electrons. So number 6 is our lowest. Number 4 is our second lowest. When it comes down to these last two, so number 1 and number 5, we've got the same situation where they're both polar and they both have the same intermolecular forces, London and dipole-dipole. that's when we have to look at the number of electrons. So H2S has 16 from the sulfur and 2 from the hydrogens. So it's got a total of 18 electrons. HCl has 17 from the chlorine and 1 from the hydrogen. So this one also has 18 electrons. So in this case, there's not really any way to tell which one is stronger. So we could say this could be 1 or 5. Okay, 1 or 5.